Hi, good morning to one and all. Today we will discuss about plasma arc machining. In this process, by using electrical energy, we are creating the some arc. Okay, is known as thermoelectrical energy. By using these, we are machining the workpiece. Coming to introduction, in this, first we have to know the what is plasma. Okay, the plasma means when the temperature of a gas is raised about 2000 degrees centigrade. Therefore, the gas molecules becomes dissociated into the separate atoms. Therefore, at higher temperatures, that is 30,000 degrees centigrade, these atoms become ionized. Therefore, this gas is known as plasma. Therefore, machining by plasma gas was adopted in 1950s, but alternative method for oxy gas flame cutting of stainless steel, aluminum, and other non-ferrous metals. Okay. Next, during this time the process limitations regarding the low cutting speed, poor machining quality, and unreliable equipment were clear. For that case, there is no development in that time. Therefore, recently machining of both metallic and non-conductive materials has become more attractive. For that case, an important feature of plasma beam machining is that it is only fabricating method for work faster in stainless steel than does in mild steel. Next, machining systems. In plasma machining, a continuous arc is generated between the hot tungsten electrode and workpiece, and also and copper nozzle. Based on the two types are there, transfer type and non-transfer type. A gas is introduced between the cathode and flow through a anode. Therefore, the temperature in the narrow orifice increases about 28,000 degrees centigrade, which is enough to produce the temperature plasma arc. Under these conditions, the metal being machined is very rapidly melted and vaporized. Okay. Next, the stream of ionized gas flushes away the machining materials, that is machining debris, as a fine spray, creating flow lines to be machined surface substantially higher than those of conventional single point turning operations. Therefore, the plasma machining systems are divided into plasma arc, plasma jet, shielding plasma, and air plasma. These are the different types. Coming to plasma arc machining, it is a diagrammatic representation of PAM. It consists of power supply and high frequency coil, next plasma gas, next tungsten electrode and nozzle, next workpiece. Here, whenever we switch on the power supply, by using the high frequency coil, here more amount of heat will generated. Due to this heat generated, the plasma gas in the it will be gets ionized. Due to this more amount of the electricity will pass through this gas. Therefore, here the nozzle is act as a anode. Due to this, some amount of heat will be developed. Due to this, whenever we heat this gas, the plasma gas should be ionized, and it act as a conductive material. Through this, the gas will pass through the nozzle. Okay. Next, plasma arc. As shown in above figure, the arc is stuck between the rear electrode of the plasma torch to the conductive workpiece, causing this temperature at high 333,000 degrees centigrade. Therefore, the double arcing effect between the nozzle and the workpiece. therefore damage the electrode and workpiece also. Therefore, high heat transfer rates are found to occur during the plasma arc due to the transfer of all the anode heat to the workpiece. Okay. Next, owning the greater efficiency of plasma arc systems, they often meshing metals. Therefore, the plasma arc does not depends on the chemical reaction between the gas and the work metal, and because the temperature is high, the process is suitable for any electrically conductive material, including those they are resistant for to oxy-fuel gas cutting. Okay. Next, coming to plasma jet. In this system, as shown figure, the non-transferred arc operated within the torch itself. In this system, the anode is given to the outer nozzle of the process. Only ionized gas is emitted as a jet, causing the temperature at high, that is 16,600 degrees centigrade. Therefore, since the torch itself is act as anode, a large part of the anode heat is extracted by the cooling water and it not effectively used in the material removal process. Okay. Next, non-conductive materials that are difficult to machine by conventional machining methods, we can machine easily by using this plasma jet machining system. Next, coming to shielded plasma. In these, when machining different materials such as aluminum, stainless steel and mild steel, gases may have to use to produce cut-off acceptable quality. For those, in such case, outer shield gas such as added around the nozzle to reduce the effect of atmospheric gas like nitrogen and argon. Therefore, it reacts with outer gases and oxidation of the metal created. Therefore, it gets very hard material. Therefore, we are using as a shielded gases. Next, the shielded gas depends on the metal being machined. For stainless steel, aluminum and other non-ferrous materials, hydrogen is used as a shield gas. For carbon dioxide is popular for ferrous and non-ferrous metals. For mild steel, air or oxygen may also be used as a shielded gas. Next, coming to water shielded plasma. As shown figure, nitrogen is used as a machining while the shield gas is replaced by water. Therefore, water forms a radial jacket around the plasma torch. Therefore, the cooling effect of water is reported to reduce the width of the cutting zone and improve quality. However, to improve the squareness of the cut, it is the diagrammatic representation of water shield plasma. Here, around the nozzle, we are passing the water supply to cool the gases, heat generated in the nozzle to reduce the wear and tear of the electrode. Next, coming to air plasma. Here, compressed air used to machine gas instead of nitrogen or argon. When air is subjected to high temperature of the electric arc, it breaks down into constituent gas. That is, since the oxygen is the resulting plasma is very reactive, especially with ferrous metals, machining rates such as 25%. Next, the main drawback of this method is heavily oxidized surface, which is frequently obtained in case of stainless steel, aluminum. Next, because tungsten is reactive with oxygen, hafnium copper or hafnium zirconium alloys are replaced by the tungsten electrodes because it will react with the gases. Next, Here the tungsten electrode is replaced by hafnium copper electrode, and by surrounding the air plasma is used. Okay, next coming to material removal rate. During PBM, absorbing the heat energy from the plasma jet direct toward the workpiece, active metal removal takes place. The plasma torch blows the molten and evaporated metal away as a fine spray or vapor, thus resulting cutting rates, and hence the machinability depend on the workpiece being machined as well as the type of cutting or and shielding gas that determine the maximum temperature transfer rates. Okay, next, as the power is increased, the efficient removal of melted metal is found to need to corresponding rise in gas flow rate. Next, during the plasma machining, 12 thick plates, thick steel plate using 220 kilowatts power and 2500 per minute, that is machining speed, and 5 times greater than the Auxville gas cutting. Next, coming to applications. Uh, PM is an attractive turning method for difficult to machine materials like conventional methods. In this regard, cutting speed, that is 2 meters per minute, and feed rate should be 5 per revolution, produce a surface finish, that is 0.5 RT. Therefore, the depth of cut can be controlled through the machining power or surface speed. This is the one of the application of PAM. Next, the computer numerical controlled PAM is used for profile cutting of metals that are difficult to tackle by the oxy-acetylene gas techniques such as stainless steel and aluminum. A large number of parts can also be produced from one large sheet, thus eliminating the shearing operations. By using this process, we can cut. Okay, next, the PBM can cut 1.5 deep and 12.5 deep wide grooves in stainless steel at 80 millimeter cube per minute, using 50 kilowatts as the cutting power, such as high machining rate, that is 10 times greater than the rate of grinding and chipping methods. Next, lower machining speed rates are obtainable when grooves are cut in non-conductive materials. Therefore, the groove dimensions, however, depends on the travel speed, power, angle, and height of the plasma. Next, the process is recommended for parts that have subsequent welding operations. Next, coming to advantages. Many advantages of the plasma technology have been mentioned, at including require no complicated chemical analysis or maintenance, use of harmful chlorinated fluorocarbons, solvents, acid cleaning chemicals, operates cleanly, eliminating the need of vapor degreasing, solvent wiping, ultrasonic cleaning, and grit busting. Requires no work exposure to harmful chemicals. Next, needs less energy to operate. Next, coming to disadvantage. The large power supplies needs 220 kilowatts are required to cut the 12 thick mild steel plate at 25 meter per minute. It requires more power. It is the one of the disadvantage. Next, the process this process also produce heat that could spoil the workpiece and produce toxic fumes. Here, more amount of heat is produced on the workpiece. Okay, it is about plasma arc machining process. Okay, here mainly we are using transferred and non-transferred plasma arc. In transfer type, the anode is given to the workpiece and cathode is given to the electrode, that is tungsten electrode, is known as transfer type. And in non-transfer type, the electrode is negative and the nozzle is positive. Therefore, is the main difference between transferred and non-transferred. Okay, and remaining the shielding gas, and based on the supply of water and air, they are also indifferent. Okay, it is about plasma arc machine. Thank you.